Hello everyone, it's Beto here with a short little video to show you how we create our data for our takeoff program and how this relates with profiles. So the first thing we do before we set up a job is we look and locate the AutoCAD drawing details and the shop drawings that we will be using to set up the project. For today's case, I'll be using 279 East Grand as an example. So to locate the AutoCAD details, drafting drawings, and they are here. Now the shop drawings are under review. Here we go. The next thing I do is I go through each detail and circle all the family names in that page. If I circle them, that means they are brand new details that need to be made. If I cross a line through them, that means that family exists. Maybe the conditions already exist, so I don't need to do anything. Or the conditions do not exist, but the family does, so I need to go in there and create the new conditions. If I cloud a family name, that means I either have a question for Tony, Esley, or Gabriel on this specific detail. Once I have done that to all the details and located all the family names, the next step is to make a unit matrix with all the conditions that there is for this job. So the first thing we do in this matrix is we list out all the silk conditions that there are on the profile stage, all the head conditions, and all the horizontal conditions that we see. If we see any extra conditions like a false stack, we also write that down. And then we do all the verticals for punched openings and curtain wall, and if they have any extended covers. Once I am done identifying all my conditions, we can start on our prototype unit. So I'm just going to take this 2V here as an example. So when we start up a job, we write down the description of what kind of unit this will be. So in this case it's a stack sail window to a stack head with captured verticals on both sides. Next we go in and edit any of the detail bubbles and also the dimension strings if we need to. Once we're done, we can start inputting all of our data with their corresponding taglines. So first, this is our data. This is the Revit family name, the detail number, a little small description, and here are our taglines. So for this case, we're using this horizontal vert to vert on both sides. So we fill in the information with the parts, their miscellaneous items with these corresponding parts, and then we run layout. So to run layout, we press this green button, but we need to be on our detail. So let me change this to the detail. There we go. Press the green button, and here we are. So if I see any part that is green, that means the die has not been approved. So we list this part out on our Trello board for the specific job as part has not been approved. As you can tell here, the detail must be precise and accurate because we lay out our parts over the detail. So if the detail is off by a 16th or a 32nd, our parts will be off by a 32nd or a 16th. So then our bin model will be incorrect. So once I have done laying out my parts, hit save, yes, apply to all changes, and then hit apply. So if we go back to our unit, now we can set up the horizontal. So now here we can change the name to whatever the horizontal tagline needs to be, change the detail, the family name, and we do that to all taglines. So we repeat that process, inputting the information, doing layout, and then renaming taglines. And once we're done inputting all the source details, all the parts, miscellaneous parts, and running layout, tagging this whole unit, we UPD it and BIM it. So once we BIM it, it looks like this. We have our 3D model, and what we do is we go through every fab and make sure that it is correct. So this is a vertical fab. We go through here and check it, make sure that we have the correct notches, correct gaskets, correct notes, callouts. If we have any attached parts, make sure that the AP drawings show up where they should be. And once you feel like your fabs are all correct, you can go back to the unit and batch print the unit along with the unit assembly drawings and the fabs into our checking folder. Now once it's ready for checking, the checking goes in there and marks up the unit assembly drawing along with the fab. Once the checker is done, we go in there and update anything that needs to be updated. So we go from the PDF back to the CAD and update anything that needs to be fixed. Once our units are complete, the last thing to do is to upload all the details to our standard detail in the server. So this is what it looks like. It has a Revit resource, family name, description, all the part use, and all the parts used in that specific use with its miscellaneous. So once we're ready to upload, we upload everything that has to do with that job, so it can be available for the person that is going to be setting up stage 2, which is metal takeoff, and for whoever's going to be doing fabs in the next stage after that. After the fabs are in the server, we go through the fabs and assign each notch a machine program. Each notch has a corresponding machine program. If it's green, it means it has been assigned. If it's red, that means it has not been assigned. So if it has not been assigned, we look for the corresponding machining. So 5262, and look for that machining. If that machining does not exist, we go and create that machining and then assign it. These notches will always have an assigned machining unless you change it or somebody physically goes in here and deletes the machining. So when operators use the fabs that are on the server, most of them should have an assigned machining to each notch. So this will help us save time when we are programming the weekly release, because most of the typical stuff will already be assigned, and most of the stuff that is not assigned would be job specific. So we will have a little bit more time to program the stuff that has not been made. We usually start 3 to 4 weeks before the metal takeoff does. This process takes about 2 weeks to complete. That concludes stage 1. Thank you for watching.